So, how do machines recognize objects in images, like identifying a fruit as an apple or a banana? This is made possible through convolutional neural networks, or CNNs for short, a specialized type of deep learning model that excels in computer vision tasks. So, what is CNN? It is one of the most widely used machine learning architectures of image related tasks, such as classification, object detection, and segmentations. CNNs are designed to analyze images by extracting important features and then use those features to make predictions. For example, in an image classification task, a CNN can determine the primary subject of an image, answering the questions like what is this image of? So let's say we train CNN with images of different fruits like apples, bananas, and oranges. The model learns to classify each imaging by predicting the type of fruit it contains. So, how does a CNN work? First, image inputs and filters. CNNs begin by taking images as inputs. The network uses filters, also known as kernels, to analyze the small patches of an image. These filters extract numeric features maps, which represent key patterns such as edges, textures, or shapes in the image. Secondly, training the filters. Initially, filter kernels are randomly assigned weight. During the training process, the CNN evaluates its predictions against the actual labels. For example, whether the image contains an apple, banana, or an orange. The filter weight are then adjusted through optimization techniques to improve the model accuracy. Over time, CNN learns which features are most useful for identifying specific objects. Third, feature maps and neural network layers. As the image passes through multiple layers of filters, more complex features are extracted. This resulting feature maps are flattened into a single dimensional array of numeric values. And then, fully connected neural network. The flattened features values are fed into a fully connected neural network. This network processes the data to generate a final prediction. And finally, the output layer. The output layer uses a function like a softmax to produce a probability values for each possible class. For example, the result of a fruit classification task might look like a 0 apple, zero point 0.5 for banana, or zero point 0.3 for orange. The model predicts the label with the highest probability, in this case, a banana. So let's bring how we train the model. Imagine you're training a CNN to classifying fruit. You provide it with labeled images, say 0 for apples, 1 for bananas, and 2 for oranges. Then CNN applies filters to identify features like a round shape for an apple, curved edge for a banana, or a dimpled surface for an orange. By training on these labeled examples, the CNN adjusts its filter's weight to reliably detect the correct fruit type in a new unseen images. CNNs are powerful tools that have revolutionized the field of computer vision, enabling machines to see and interpret images with impressive accuracy.